Hello and welcome back to another ID Math speedrun with me, Vince. Today we're going to be going through chapter 3.3, which is all about polynomials, and yeah, that's pretty much it. So let's jump right in. So the first thing we need to cover is, well, what is a polynomial? So polynomials are functions that map a real variable to another real variable. It's as simple as this. And they are also of the form f of x is equal to a to the 0 plus some other constant times x plus some other constant times x squared, all the way until some maximum numbers. So a to the n times x to the n. And yeah, so these letters a, all of these constants, are called the coefficients, and the highest power, which is what n is called the degree of the polynomial. So we've already met some polynomials before. First of all, any constant like y equals 0 or y equals 2 is a polynomial with degree 0. And then now we have our linear expressions, y equals, say, 5x plus 4. This is also a polynomial with a degree of 1. We know our quadratic expressions, y equals, say, x squared plus 2x plus 1. And this is a polynomial of degree 2. And yeah, this goes on and on forever, and there's an infinite amount of degrees. So yeah, that's what a polynomial is. So we need to know some other things along with that. First of all, a linear combination of two functions, f and g, is an expression of the form a times f of x plus b times g of x, where a and b are real numbers. So that's just linearly adding the functions together. And so a linear combination of n functions is an expression of the sum from I equals 1 to n of a to the I times f of I to the x. So this is more or less saying if you want to add n functions together in a linear combination, a linear combination of n functions is going to be those functions added together, or the sum of the functions. So yeah, all polynomials are linear combinations of the power functions. So for example, x squared plus 2x plus 1 is a linear combination of the functions x squared, x, and 1. Just, and so it's a linear combination. You might ask, oh, why is it 2 here? Well, remember, in linear combinations, we can have coefficients multiplied to the functions. So in this case, we multiply x by 2 to get 2x. Yeah. Is there anything else we need to know? Oh, we need to know one other thing. It's like a theorem we need to know. And it's for any two polynomials, f and g, there are unique polynomials that will allow us to express f of x, in terms of g of x times, say, we have another function, q and r. And all polynomials can be expressed in this form. So you might think of this as like a sort of linear function. It's sort of, not really, but it means that we can express any polynomial as another polynomial multiplied by some quotient plus a remainder. So we call this function q of x the quotient. It's like when we divide f of x by g of x, and we call this r of x function the remainder. So yeah, that is pretty much it. And so let's get into some questions. I guess there is one other thing I must say, and it's that you need to be able to do polynomial long division, and let's look at some questions regarding that. So we want to divide 2x cubed plus 5x squared minus 11x plus 4 by x plus 4. So Well, how do we do this? Well, we're going to use the same long division method as you might have learned in like primary school. Say we want to divide 2048 by 4 or by 8. Well, how do we do it? So first we take the first digit, 2. Does 8 go into 2? No. So then we get the second digit. Does 8 go into 20? Yes. How many times? 2 times. What's 2 times 8? 16. So we put 16 here, and we subtract 16 from 20, getting 4. Does 8 go into 4? No. So we bring down the next digit. Does 8 go into 44? Yes. How many times? It goes in 5 times. What's 5 times 8? 40. So we have 40 over here. And finally, we drop 4. Okay, does 8 go into 4? No, so we drop the 8. Does 8 go into 48? Yes, it's 6. So what's 6 times 8? 48. And so we're left with a remainder of 0. And that's how we divide 2048 by 8. I mean, yeah. So it's the same thing for polynomials. It's just that this time you have to bend your head a little. So let's try an example here. Let's divide this polynomial by this number. So what does x plus 4, so the thing is, for the number of terms here, we have to have at least the number of terms on this side. And let me explain how this works. So first, we want to divide 2x cubed by x plus 4. How do we do that? Well, we need to multiply this entire thing by 2x squared in order to get some form of a polynomial that we can subtract from 2x cubed. So this will be first 2x squared, multiply 2x squared to x plus 4, and we get 2x cubed plus 8x squared. And now we can simply subtract these two polynomials, getting negative 3x squared. Sorry, this should be 3 and this should be 2. Now, next, well, we need to drop down another term, so minus 11x. And now we need to ask ourselves, how many times does x go into negative 3x? And the answer is negative 3x times. So yeah, it might be a bit mind-bending, but this is how it works. Negative 3x times x plus 4 is equal to negative 3x squared minus 12x. So as you can see, we're just eliminating parts of the polynomial term by term. So where is my, yeah, so sorry about that. So we divide this and we get x plus 4. Since negative 11 minus 12 minus 12 is equal to 1, so we're left with x plus 4. Well, how many times does x plus 4 go into x plus 4? 1 time. So we have this final polynomial up here. So we know that 2x cubed plus 5x minus 11x plus 4 over x plus 4 is equal to 2x squared minus 3x plus 1. This is also the same as factoring out x plus 4 from this polynomial. So this allows us to write this as x plus 4 times 2x squared minus 3x plus 1. So this is equal to that. So we have, yeah, that's it. So let's try another one. Well, this time we have quite a long one. Gx equals x squared minus x plus 3. And we need to divide x to the 6 minus x to the 5 plus 2x to the 4 minus, plus x cubed minus 5x squared plus 2x minus 6. Quite a long polynomial, but I'm sure we'll be able to do it. So first, how many times does x squared go into x plus 6? We want to eliminate the first term, and the answer is, oh, x to the 4 times. What's x to the 4 times this entire thing? Well, that will be x to the 6 minus x to the 5 plus 3x to the 4. Subtracting these two, we get negative x to the 4. Well, since this is a 3-term polynomial, we need to drop the next 2 terms down this time. So this is negative x to the 4 plus x cubed minus 5x squared. Well, how many times does x squared go into negative x to the 4? It goes in negative x squared number of times. So we have negative x to the 4 plus x to the 3 minus 3x squared. So this becomes, well, this minus that, 0, this minus that, 0, this minus that, it will be negative 2x squared. So finally, we drop these two terms down, and we have negative 2x squared plus 2x minus 6. Well, how many times does x squared go into negative 2x? It's negative 2 times. And negative 2 times this entire thing will be equal to this equation. Yeah, and so we have this divided by that will equal x to the 4 minus x squared minus 2 with no remainder. And yeah, that's it. Okay, on to some different questions. So in this case, the polynomials, when we divide them, will have a quotient, but they will also have a remainder. So we need to find both of them. So the first polynomial we're going to do is 3x to the cube minus 6x squared plus x minus 1. And we can divide that by x minus 1. So how many times does x go into 3x cubed? 3x squared times. What's 3x squared times x minus 1? That's 3x cubed minus 3x squared. And so if we subtract these two, we'll get minus 3x squared. Drop down this term plus x. Well, how many times does x go into negative 3x squared? Negative 3x times. So we then have negative 3x squared plus 3x. And this minus that, negative 2x minus 1. So how many times does x go into negative 2x? It goes in negative 2 times. So what's negative 2 times x minus 1? Well, that's negative 2x plus 2. So in this case, we subtract that, we're left with a remainder of minus 3. So the quotient, it will be equal to 3x squared minus 3x minus 2, and the remainder is minus 3. So another thing this tells us is that x minus 1 is not a root of this equation, because all roots should be able to cleanly divide the equation. Okay, on to the final question. We need to do x to the 5 plus x to the 4 plus 1, and divide that by x cubed plus 1. Okay, well actually let's add some spaces, because this will be a longer problem than you might expect it to be. Because we need to remember this is equivalent to also plus 0x cubed plus 0x squared plus 0x plus 1. Yeah, okay, so how many times does x cubed go into x to the 5? It goes in x squared times. Yeah. And so we have x cubed times x squared is x to the 5, and 1 times x squared is x squared. So if we subtract this, we're left with, well, that's 0. We'll drop this down to become x to the 4, plus 0x to the 3. And 0x squared minus x squared will be equal to negative x squared. And then we'll drop this 0x down. Okay, now, how many times does x cubed go into x to the 4? It goes in x times. And so what's x cubed plus 1 times x? Well, that's x to the 4 plus x. So now when we subtract these, x to the 4 minus x to the 4 is 0. We're dropping 0x cubed here. Minus x squared minus x plus 1. And so finally, x cubed can no longer divide 0x cubed, which we, if we'll remember, it's 0. So we're left with x squared minus x squared minus x minus 1 plus 1. Since x cubed cannot divide minus x squared, we're left with this as a remainder. So your remainder can easily be a function in itself. In fact, it normally is. So when we divide this by that, we get x squared plus x with a remainder of negative x squared minus x minus 1. So yeah, that seems like all. So, yeah, I guess that was it for this speedrun, and I hope to catch you in the next speedrun. See you then.